Hey there, we're going to do section 6.1, volumes by cross-section and solids of revolution. All right, guys, so there is a way to figure out what a solid is if you're revolving it around an axis or a line. So let's check these out first. So we're going to do volumes, and we're going to construct the volume by using cross-sections. So let S be a solid bounded by x equals A and x equals B. So that's my starting point and my ending point, okay? All right, cross-sections perpendicular to the x-axis have cross-sectional area. So here's the area, like of one of them, is A at x. Then the volume of the solid is given by volume equals, we're going to integrate from A to B the area of x dx. So if you integrate area, you get volume. That's how this is working, okay? And then secondly, let S be a solid bounded by y equals C and y equals D. So I'm looking at the second figure here. And then we make cross sections of the area. So in this case, we're making square cross sections. Then the volume of the solid is given by volume equals the integration from C to D, the area at y dy. Okay, so a word of warning, when we're doing these, it's very important to draw the function, because if you don't draw the function, you are not going to know if you're making cross sections that are going to be vertical or cross sections that are going to be horizontal, okay? And so the first thing we're going to look at, we're not going to worry about these squares, like integration with squares, but we are going to integrate by using cross sections that are discs. So a disc sounds exactly like what you think it is. It's a circular region, and that circular region, we're going to be concerned with finding the area of that circular region. So the area of a circle is pi r squared. So that's where they're getting this function, pi r squared. Okay, so if I'm revolving around using circular discs where the width is delta x, or it could be delta y, just depending on how you slice the thing, we can get the volume of the solid of revolution by taking the volume equals integration from where it starts to where it ends, pi times whatever the radius is squared, and then d, this should be x or y. By the way, the radius is going to be your function. Okay, so this is very important. Your radius is going to be your function. All right, so when we look at this, we can have discs that are either vertical slices or discs that are horizontal slices. If a disc is cut with vertical slices, you are revolving around the x-axis. So this is the axis of revolution. Here's a little symbol that shows me I'm revolving around the x-axis. So here's my function. So my radius is basically from the x-axis out to my function, okay? And if I revolve that radius around, I get that circular region, okay? So if I get several of these, so if I keep on making several circles, it would create this shape, all right? So what do we do here? If we are doing vertical slices, then the region is bounded by x equals A to x equals B. So this would be x equals A to x equals B. We are going to take pi times the radius squared. So the radius is going to be the function f of x, and we need to tack on dx because we're integrating around the x-axis, okay? And once again, this is for vertical slices. So how do I determine if they're vertical or horizontal? You got to draw the function, okay? The next thing we're going to talk about is discs that we're going to slice using horizontal slices. So this time around, my area is bounded by x equals y, x equals g at y. So we're going from some value, here, C, to some value D here, okay? So when you revolve around the y-axis, my radius is going to be coming out from the y-axis to the function. Okay, so what I'm going to do is I'm going to integrate from the lower limit to the upper limit. So I'm integrating from c to d, pi radius squared. This time around, the radius is g at y. I keep on saying that backwards. So g at y squared dx. So by the way, your function has to be written as x equals blah, 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 blah. Okay? For the vertical slices, it's going to be y equals whatever. Okay, so just make sure that your function changes up with that as well. Okay, so let's go ahead onward, and we're going to look at an example and see how this plays out. So the first one we're going to look at is example number 1. Find the volume of the solid formed by revolving R about the indicated axis. Okay, so really important. If you do vertical slices, you integrate with respect to x. And if you do horizontal slices, you're going to integrate with respect to y. You just have to memorize that, okay? So step number 1 is to draw the function. Okay, so I'm drawing out my function. It is y equals x squared, or excuse me, it is y equals square root of x. And I'm looking where x equals 1, and then it goes to where x equals 4. Okay, so here's the x-axis, here's the y-axis. And it tells me that my function is square root of y. It's bounded where x equals 1 to x equals 4 about the x-axis. So let me just make myself a note that I'm going around the x-axis. So if I draw my function, I can plug in for x, right? So the square root of 1, when x equals 1, is 1. And I go up to 4. The square root of when x equals 4, the output's 2. So my function looks like this. Okay? And it's going to start at 1 and end at 4. Okay, so this now becomes my radius. So my radius, are, values in here from the x-axis out to my function, right? If I'm revolving this around, I get what I call the ghost function. So the ghost function, is just the negative of what we just saw. So here's 1, here's 4. So, it's symmetrical about the x-axis. So here's what's happening, is I'm taking slices here that are going to be circles, okay? So this is what I am doing. I'm revolving those radii about the x-axis, and that's going to form a shape that looks like this. So I'm just going to re-put x equals 1 to x equals 4. Okay, so I'm integrating with vertical slices, so I know I have to integrate with respect to x, okay? So I'm going to integrate from 1 to 4, and I'm going to integrate pi times the radius squared dx, okay? So what is the radius? The radius is your function. So this becomes integration from 1 to 4. I'm going to kick the pi out. The radius is x to the 1/2 power. That's the square root of x, and I have to square that, dx. So x to the 1/2 squared is just x. So I'm integrating from 1 to 4. So let's integrate that. So if I integrate this, the integration of x is x squared over 2, or remember I have to multiply that by pi, so it's going to be pi over 2 x squared. I'm integrating that from 1 to 4, which is the lower and upper limits. So I'm going to take f at b minus f at a. Okay, so I get pi over 2 times 4 squared minus pi over 2 times 1 squared. Okay, so 4 squared is 16. 16 divided by 2 is 8. So I get 8 pi minus 1 squared is 1 times pi over 2 is pi over 2. So if I find a common denominator, it's going to be 16 pi over 2 minus pi over 2, which gives me 15 pi over 2. So that is the volume of the solid revolving around the x-axis. Okay, so let's look at the next one. The next one says that, find the volume of the solid formed by revolving R about the indicated axis. We have the same function, but this time it says y equals 2 and x equals 0 about the y-axis. So once again, I'm going to draw my function out. So when x equals 1, we know y equals 1. And when x equals 4, y equals 2. So my function, remember, was this. Okay? And this time around, it's saying that I have to bound it where x equals 0. So I'm going to drop my function down because the square root of 0 is 0. To when y equals 2. Okay. So that means that I'm taking this area here and I'm going to revolve it around the y-axis because that's what it said to do. So if I'm revolving it around the y-axis, I get the ghost function on the other side. And the ghost function looks like this. Okay. So what's happening is if I revolve around the y-axis, I'm getting these slices here. And this is what my figure looks like. Okay, all right. So I have my figure, and I know it's revolving around the y-axis. So if I have horizontal slices, that means I have to take and integrate with respect to y. Okay, all right. So if it's respect to y, my starting point is when y equals 0 to y equals 2. Okay, so I'm going to integrate from 0 to 2 pi times the radius squared dy. Okay, my function is in terms of x, right? So y equals square root of x. So I have to write this in terms of x. Okay, so I've got to get x isolated. So to do that, I'm going to square both sides. And I get y squared equals x. Okay, so my radius is coming out from the y-axis to the function. So my radius is coming out from the y-axis to my function. So my radius is just my function. Okay, so let's put these values in here. From 0 to 2, kick out pi. The radius is y squared. And I'm going to square that dy. Okay? So when I do this, I get pi from 0 to 2 of y to the 4th dy. Okay, now we have to integrate this. So I get y to the 5th over 5. And remember we have pi there. So I have pi over 5 times y to the 5th. And I'm going to integrate that from 0 to 4. Or 0 to 2. I'm sorry, I wrote down the wrong value. I just caught that. Okay. All right, so I'm going to do f at b minus f at a. So f at b equals pi over 5 times 2 to the 5th power minus pi over 5 times 0 to the 5th power. So this becomes 32 pi over 5 minus 0. So your volume is going to end up being 32 pi over 5. Okay, so there's that one. And I'm going to do one more before we do a break in the video. if we have an axis of revolution other than the x-axis or y-axis, you're going to need to figure out what your radius is. Okay, so this is going to be important. All right, so example 2 says, find the volume of the solid formed by revolving y equals 2 minus x squared, y equals 1 about the line y equals 1. Okay, I'm going to first rewrite my equation. So it says negative x squared plus 2. So I know this is a parabola upside down because it's a negative, and I know I have to raise up the parabola 2 units up. Okay, so what does this look like? So here's negative 4, negative 2, positive 2, positive 4, 1, 2. Okay, so if I have a parabola, a regular parabola, and I just have to move it up 2. So the parabola starts at 2, and then we have values here. And we also need to draw in the axis of revolution. So the axis of revolution, here's my parabola. Let me put that in there. And here's the axis of revolution, which is y equals 1. Okay, so the one side of the form is this. Okay, so before I continue, because remember I have to do the ghost, I can tell right now that the way I have this drawn, I'm going to have to find the radius. Now the radius this time around is from the line y equals 1 out to the function, right? So the ghost function is going to look like this. So I'm slicing with vertical slices. Okay? Okay, so we know that they're vertical slices. So I have to integrate with respect to x. Okay. All right. So a couple questions here. Here's where I start and where I stop, right? Those are my x values because I need the upper and lower limits of integration, but I'm not sure exactly where those are touching. So what I can do is I can find the places. So to find the upper and lower limits of integration, if they aren't given to you, is you're going to set the axis of revolution equal to the function. Okay, so the axis of revolution is y equals 1. And I'm setting that equal to y equals negative x squared plus 2. And then I'm going to solve for x. So negative 1 equals negative x squared. And then we get 1 equals x squared, right? To get x squared by itself, I take the square root of both sides. Remember, you get plus or minus. So I get plus or minus 1 equals x. Okay, so now I have the upper and lower axes of revolution. So I'm going to draw this out. I know it's going from negative 1 to 1. Pi times my radius squared dx. Okay, the radius. This is the tricky part. To find the radius when it is not on the x-axis or y-axis, you got to think about what's going on here. So what I'm going to do is I'm going to highlight what I'm looking at. So my radius is coming out from the line y equals 1 out to the edge. So to find the distance between the function and the y equals 1, I'm going to have to subtract the 2, right? So I have to find the distance from the function to the axis of revolution. We didn't have to subtract the 2 before because we were right on the y-axis or right on the x-axis. So if I do that, the distance of the function to the axis of revolution, this is going to be the function negative x squared plus 2, and then I'm going to subtract the line y equals 1. That'll give me the distance from that axis out to my function. Okay? So if I do the math, I get negative x squared plus 1, negative x squared plus 1. This is my radius. Okay? So I'm going to integrate from negative 1 to 1 pi negative x squared plus 1 squared dx. Okay? Next, I'm going to have to expand that out so I can integrate it. So I'm going to kick out the pi. I'm going to square negative x squared plus 1. And when I do that, I get x to the 4th minus 2x squared plus 1 dx. Okay? So my next step is to integrate it. So we're going to integrate this. So x to the 4th becomes 1/5 x to the 5th. Negative 2 x squared becomes negative 2/3 x to the 3rd. And then 1 becomes x. And remember, when I integrate this, I have to multiply everything by, pi. So to make this look better, I'm going to do pi over 5 x to the 5th minus 2 pi over 3 x to the 3rd plus pi x. Okay, and what am I integrating over? I'm integrating from negative 1 to 1. Okay, so now I just have to plug stuff in. So f at b minus f at a. Okay, so f at b is pi over 5, 1 to the 5th minus 2 pi over 3 times 1 cubed plus pi times 1 minus pi over 5 times 1 to the 5th minus 2, and this should be a negative 1, minus 2 pi over 3 times negative 1 to the 3rd plus pi times negative 1. Okay, so I get pi over 5 minus 2 pi over 3 plus pi. And now I have negative 1 to the 5th. That's going to give me a negative 1. And I have this other negative hanging out in front. So a negative times a negative gives me a positive pi to the 5th. And then a negative 1 to the cubed is negative. A negative times negative is a positive. But then I have this negative hanging out. So it's negative 2 pi over 3. And then a negative 1 times pi is a negative pi times a negative is a positive pi. Okay, so I get 2 pi over 5 minus 4 pi over 3 plus 2 pi. Okay, so all I have left to do now is just to do a little bit of math here. If I find a common denominator, it's going to be 15. So 2 pi over 5 becomes 6 pi over 15 minus 5 times 4 is 20 pi. And then 2 pi is going to become 30 pi. So 30 minus 20 is 10. And then I have this 6 here. So if I add these together, I'm going to do 36 pi over 15 minus 20 pi over 15. I'm just combining like terms. And when I do the math, I get 16 pi over 15. And that is my volume. Okay, so if you need to watch this a couple times over, watch it again if you didn't really get it the first time.